All right, on the bottom of 208, we're going to do our first proof. So let's take a look at it. First thing they do is we'll write the given, then we'll write the picture, and then I'll show you how to set up a proof. This is a formal proof. We've talked about proofs before. We've mentioned it. I'm like, well, this is kind of what we're thinking when we're thinking a proof, of trying to get you into it kind of in an informal way. But this is an actual formal proof, the kind of stuff that we're going to be doing in here. And so it says given that angle 1 equals angle 2. I'll draw the picture in a second, all right? So you have no idea which angle is what until you see the picture. And then that's all they tell you, and they tell you to prove L is parallel to M. All right, and here is your picture. They just give you your basic 2 lines cut by transversal thing. They say that this is L, this is M, it's angle 1, this is 3, and this is 2. Alright? So that's how you set it. That's how we set it up. This is what they give you. Okay, you don't have to figure out any of this stuff. This is what they give you. They tell you what's true. Alright, they'll give you something that's true about this picture. They'll ask you what they want to prove, okay, that L and M are parallel to each other, and they'll give you the picture with the angles and all that good stuff. Alright? This is how we set this thing up. We set it up, we call this a 2-column proof. So let's write 2 columns in here. Okay, the first column are for statements, and we write that above it. Okay, we're going to state some facts, but then we have to tell why these facts are true. Okay, we have to give reasons for these facts, and we've talked about this before. If you remember when we did, if I said why is angle 1 and 2 equal, or why is 1 and 3 equal to each other, and I said give me a reason, and right? So I've been leading you up to it, and you probably didn't even realize it, but I have been leading you up to it to give me reasons to back up why you say a certain angle is equal to something. We've talked about vertical angles equal to each other. We've talked about all kinds of stuff. Perpendicular lines form right angles and all that. We've had all these different reasons for things being true, for angles being equal or angles being supplementary or whatever the case may be. So we have to justify our statements with a reason. We got to back it up. We can't just say this is true and then not back it up, right? Just like on DE preps. They say a lot of things, but they don't back it up, all right, with fact. And I'm sitting there yelling at them, you don't know what's going on. All right, so that's what's going on here. Thank you, Trevor. So let's put in some statements. What they're going to do, they start you off real easy. They actually start you off with some statements to begin this. But before we even write anything down here, what I want to do is I want to go through this and let's figure out why in the world would L and M be parallel to each other. We went through a whole lesson, we just talked about it, on some reasons why these 2 lines could be parallel to each other. But first of all, let's do this. I'll get to you in just a second. What about this? 1 and 2 equal to each other. First thing I do is I take the given, I come over to the picture, and I draw that, I label it on my picture. So it stands out to me so I can see what's going on. So 1 and 2 are equal. How do I show on my picture that 1 and 2 are equal? The little thingy, right. Yeah, put a little John right there. Okay. How's that? That's on YouTube for everybody to hear. Old white guy saying John, okay? So there we go. So 1 and 2 are equal to each other. I don't know what I'm going to do when my kids all leave the house and I don't know any of these words, and people are going to be saying all these words in class, and I'm like, I have no idea what you're talking about. See, at least now I recognize a lot of these words because of my kids, but once my kids are gone, I'm gonna be like that old guy, that doesn't know anything that's going on, that's stuck in the 70s or whatever. So maybe you probably think I'm that guy already. I don't know. All right. So anyway, here we go. We know that 1 and 2. Now, is there a direct relationship between 1 and 2? Yeah, they are. They're what? Alternate exterior angles, aren't they? All right. We don't even have to go with this angle 3. This angle 3 is really not doing much for us at all. In fact, they do it. They do it another way. Oh, you know what they're doing? I should have read this. They say this is a proof for Theorem 3.5. What is Theorem 3.5? Let's take a look at it. Now, I told you you didn't have to memorize the number of theorems, but what is Theorem 3.5? Where is it? There it is. It's on page 206. Everybody see it? It's in that box. It's that top one.
Yeah, dude.
We're trying to prove that alternate exterior angles, if the alternate exterior angles are equal to each other, guess what must be true about the lines? They're parallel. Now listen to this. We are trying to prove that this is true. So we can't use this as a reason. Do you hear what I'm saying? Hang on. Never mind. All right. So look, we got to listen. There's a lot of talking, okay? This back and forth needs to stop. You're going to need to pay attention to what I'm saying. This is very important. Okay? Now watch. We're trying to prove that 1 and 2 are equal to each other. I'm sorry. We're trying to prove that the theorem that says if the alternate exterior angles are equal, oops, what did I put a dash there? Put a dot. Then what? Then the lines are parallel, right? This is what we're trying to prove. So we can't use that as a reason in our proof. We can't just say, hey, why is 1 and 2 equal? Because alternate exterior angles are equal, so the lines are parallel. Well, we're trying to prove that in the first place. It's kind of like in English. You ever hear in English, you can't use a word to define itself? Like if I said define this desk, you say, well, that looks like a desk. Well, that's not a definition of desk, is it? You ever hear that in English? Anybody heard that? When you can't use a word to define the word itself, right? It's kind of the same thing. If I'm trying to prove that alternate exterior angles, if the alternate exterior angles are equal, then the lines are parallel. If I'm trying to prove that, I have to go back before I learn that to prove that those two are equal. So this is what I know. Okay, I want to prove that if 1 and 2 are equal, then the lines are parallel. So I got to have something else before that. Yes?
Aren't the lines equal because...
The lines aren't equal. We can't say the lines are equal. Parallel. Okay.
Because angles 3 and 2 are vertical, and they're the same thing. And so the vertical angle of angle 1 would be equal to angle 3 because they're alternate interior.
Okay. You put an extra step on there, and you could do that, but we can do that. I see exactly what you're saying, but we can do that without this vertical angle right here. We can go directly from 1 to 3. So watch what I'm doing. It may not make complete sense right now what I'm saying, but I'm trying to prove that this theorem is true. So I can't sit here and say, oh, these lines are parallel because the alternate exterior angles are equal. Right? I can't do that because that's what I'm trying to prove in the first place. Does that make any sense at all? I'm trying to prove that true, so I can't use that reason as a proof, as a reason in my proof, if that's what I'm trying to prove. I'm trying to prove this is true, so I got to use something that I've learned before that, right, in order to prove that if the alternate exterior angles are equal, then the lines are parallel. As time goes on, you'll understand a little bit more what I mean. Right now, it might be a little foggy, okay? But just bear with me right now. So watch. Okay, let's do this. We know that 1 and 2 is equal. All right, Chandler, tell me something else. You were leading up to it. What else can you say about angle 2?
That it's equal to angle 3.
That's right. That's right. It's equal to angle 3. Do you see that? Why is 2 equal to 3? He said it. Because vertical angles are equal. So guess what I can do in my picture? I can mark that with an arc right there, okay? So watch. 1 is equal to 2. Tell me why. Why is 1 equal to 2? No, we can't. Remember, we can't say that. We don't know these lines are parallel, first of all. But, no, 1 and 2 aren't corresponding.
Because 1 and 3 are corresponding.
Jasmine, say it. What is it? No, why are 1 and 2 equal to each other? It's right there on the page.
Because they're alternate.
It's given, right? They told us. It's given. It's given. Look, they told us right there. All right? You guys are looking way too hard. All right? So 1 and 2 are equal to each other. Give me a reason. It's given. And that's exactly what we write. On our proof, we write given. So let's write that down. So angle 1 equals angle 2. And what's my reason for that? It's given. That's always nice. All right? So that's where we start. So 1 equals 2. Now, what else do I know about either 1 or 2? Let's say 2. We just talked about it already. Well, no, we're not going to go with the alternate exterior, okay? Because remember, we're trying to prove, listen to me, we're trying to prove that if the alternate exterior angles are equal, then the lines are parallel. We cannot use that as a reason in our proof. It's like defining a word with the word itself. You can't do that. So if 1 equals 2, look at this situation. Look what's going on. Hang on. You've answered it already. I want somebody else to get a chance. So if 1's equal to 2, tell me something else about angle 2. Alyssa, you see it, don't you? 1's equal to 2. What else is true about 2? 2's equal to 3. That's right. Okay, so watch. I can say that angle 2 equals angle 3. Give me a reason. What is it? They're vertical angles. And what we write is this. We write vertical angles are congruent or equal, whatever you want to say. It doesn't matter to me. Vertical angles, I'll just say are equal. I just shorthand it a little bit, make it a little quicker to write. So vertical angles are equal. That's my reason why two, and you don't just say they're vertical angles. All right? Just because they're vertical angles isn't a good enough reason. You have to say that vertical angles are equal or congruent. That's a theorem that we learned a little while back. Do you remember that? Okay, so that's our reason. Now watch. If 1 equals 2 and 2 equals 3, Demir, what do you see?
1 equals 3 because they correspond.
Well, it's true that 1 and 3 are corresponding, but does 1 equal 3 because they're corresponding angles?
No,
Corresponding angles?
obtuse.
No, because you don't know these lines are parallel yet, do you? Okay, if you knew the lines are parallel, then you could say 1 and 3 are equal because they're vertical angles. Here's a reason you probably haven't seen before. Here's a thing that, remember we skipped chapter 2? Here's a thing in chapter 2 that they talk about. It's called the transitive property. The transitive property says this, and we'll have to stop every once in a while and go through some stuff that we might have skipped in chapter 2. Transitive property says this. If A equals B and B equals C, then what do you think? A equals C, that's right. That's called the transitive property. Write that down. Is that Morse code or something? So we call this the transitive property. You're going to see this quite a bit. This basically is kind of like not a distributive property, but a substitution property. Watch. If A equals B and B equals C, look, B and C are the same, aren't they? So what can I do? I can replace that B with what? A C. Do you see how that's kind of like substitution? That's basically what it is. But transit is kind of nice because it goes right in line. If A equals B, B equals C, then A equals C. Or in this case, instead of A, B, and C, what? If angle 1 is equal to angle 2, and angle 2 is equal to angle 3, guess what? Angle 1 is equal to angle 3. Now, what's the reason for that? Transitive property. Okay, so I shorthand transitive and I shorthand property. Okay, transitive property. Now, big deal. Who cares if 1's equal to 3? What are we trying to prove? We're trying to prove that the lines are parallel. Well, it is a big deal because watch. Jameer, you're alluding to this a little bit earlier. If 1's equal to 3, which it is, isn't it? What are they? They're corresponding angles, aren't they? If the corresponding angles are equal, then guess what? Then the lines are parallel. It's exactly what we wanted to do. So let's write that. So what we can do is say this. Now we can say that L is parallel to M. Why? If the what? If the corresponding angles are what? Equal, then what's true? The lines are parallel. Again, I shorthand. I'll leave a few words out, but that's good enough. Let me see if that's right. Yep, that's basically what they wrote right there. And that's our proof. That's our very first proof that we've done. So what did we just do? We proved that what? If the alternate exterior angles are equal to each other, then guess what? The lines are parallel. Remember, corresponding angles was a postulate? Remember, this right here was a postulate. You don't have to even write the word postulate. All you got to do is, okay, this was a postulate that we learned. A postulate doesn't have to be proven, does it? Just accepted without fact. But a theorem, what can you do with a theorem? You can prove a theorem, and that's exactly what we just did. We proved the theorem that said, if alternate exterior angles are equal, then the lines are parallel. We just proved it. Now, since we proved it, now we can use that in a proof if we wanted to later on. All right? We don't always have to go back to corresponding angles. But this was a postulate, and there's our proof. Look, at first, these are a little confusing. Okay? And I understand that. I completely understand that. Thank you. But after a while, you start getting used to it and starts making a little bit more sense. The thing that you have to remember is that you got to write down some statements, and then you got to back up everything with a reason. And that's the big deal. Okay? I think we have a few more minutes to do one more proof. Okay?